What we got?
What's up, Nathan?
The Dome. How you doing, Ken?
I'm all right. How are you?
Great, bro. Thanks for asking.
So, I was I'm the guy that was talking earlier about the pressure, the atmospheric pressure.
Where was
I'd
that?
left you. Oh, I was left it on a video. So I've been watching you for probably 3 weeks now, and Nathan, he's so crazy, you know. Um, and his big thing is the laws of thermodynamics,
Yeah,
you know.
they're laws.
And yep. And so I do commercial heating and cooling. I'm a pipe fitter up in Minneapolis, and one of the things that I have to do when repairing cooling is create a vacuum in the space, in the system to get rid of all the oxygen and non-condensable gases. So I've worked with vacuums, and I've had to study the laws in my schooling. I am a flat earther, 100%. There's no proof of spin, no proof of curvature, and I was under the impression that it violates the laws, you know. And my uncle, he's a lawyer, guy's just brilliant, right? And I'm talking to him about flat Earth, and he's old, he's like 60, so it's kind of like talking to a brick wall, you know. But I was going over how it violates the laws, and he's like, dude, you need to go back to your textbooks and read what positive and negative pressures are. He's like, you can't. There's no such thing as a negative pressure. So I'm like, okay, dude, whatever. I'll go look. So I'm looking at the pressure conversion charts, and point one is a positive number, right?
It's less than one. We had this
It is
debate.
less than one. I agree.
We had this debate the other day.
But is negative one a negative number?
Yes, -1 is a number.
Yep. And that is negative, correct?
Negative, yeah. But 10 to the -17 torr is a negative number.
It's a positive number. So look at it like this. 1 is a whole number, right? But 0.1 is 1/10 of a whole number. Right? 0.1 is not a negative number. It's 1/10 of a positive number. No matter how many decimal points you go out, it's still, whether it's 100th or 1,000th or a quintillion, it's still a portion of a positive number. You know what I'm saying?
Yeah, sure. I haven't looked too much into this. I have a friend who will debate this.
So that's where I'm like, so I'm seeing so many of us, because I've been debating it for months now, that it violates the laws. What I understand now, that I've looked at my textbooks and did the conversions, 0 torr would be a perfect vacuum. And you agree we cannot achieve that, right?
Yeah, we can't achieve a perfect vacuum. We can't even achieve the vacuum of space.
Right, exactly. We can't do it. And I don't even know that the vacuum of space is a perfect vacuum. I don't think it is. Even the globalists or whatever want to claim that it isn't perfect. It's 0.000001 or whatever, you know. So it's still a positive pressure. So technically, no matter how many decimal points you go down, unless you go to a negative, it's not violating the laws of thermodynamics. Until it goes past 0 into a negative.
But you're saying we can't even create that.
We can't.
Okay, so you have the Sandusky Research Center. They suck out all the air.
Yep, and they get down to like what, the 10 to the -6
13
or something?
or I don't know. It's
not even close to what they say the space station's at.
Yeah, and so they have 8 feet walls, reinforced steel and concrete.
Right.
And if you remove the walls, what happens to the vacuum?
Well, it gets the pressure from outside the
fills
atmosphere
the
would
space.
opaque the
Yeah,
vacuum.
it fills the space. Yeah, and if it
Absolutely.
didn't, that would violate the second law of thermodynamics.
Right. So
So
at
that's
the very top of Mount Everest, do you know what the torr value is?
torr. No, I don't. Wouldn't it still
Okay,
be psi?
so, well, they say that like at sea level, it's 760 torr. It's just like the vacuum that they're claiming is 10 to the minus 17 torr, right? At sea level, it's 760 torr. Well, if you go up to the top of Mount Everest, the pressure is 500 torr. So technically, if you're standing at the top of Mount Everest, you're in a vacuum.
No,
Compared to
not even close, dude. You're talking
Absolutely.
500, 200, 700 to 500 torr being a vacuum.
Absolutely.
The top of Everest being a vacuum.
It's a vacuum compared to sea level. If sea level is at 700, so let's just say at sea level you have your trying to explain this. So at sea level you have your vacuum pressure tank like at NASA, right? Before they turn any pumps on, it is 760 torr in that room. They can turn the pump on and pump it down to 500 torr. They have now created a vacuum of 500 torr.
It's not a vacuum until it goes negative, as far as I'm aware.
It never goes negative. It will never go negative. A negative would be a perfect
10 to the
vacuum.
negative 13 torr is negative.
No. A 0.1 is a tenth of a whole number. That's where I'm trying. So negative 1 would be like a negative sign, like a dash, and then a 1. That's a negative.
10 to the negative 17 it's a negative pressure system.
We're only talking about a decimal point.
Is it sucking? Are the air particles sucking inward, or are they bouncing off the walls, creating air pressure? They're sucking inward.
It's sucking inward.
Negative pressure.
Well, no, technically, the vacuum isn't sucking anything.
Yes.
The
vacuum,
pressure is,
that's what a vacuum does. It sucks.
No.
That's why we have vacuum cleaners. Do you think space blows air on us, Ken? Is it blowing air on us?
A vacuum removes the atmosphere, and all that happens then is the atmosphere is now acting upon the vacuum. According to the laws of thermodynamics, high pressure always acts upon the lower pressure. The vacuum isn't sucking anything. The vacuum is removing atmosphere, and the pressure of the atmosphere outside of the chamber is acting upon it. There is no suction, only the pressure of the atmosphere outside of it.
Ken, do you think the 10 to the negative torr, 17 torr vacuum of space doesn't violate the second law of thermodynamics with our pressurized atmosphere bouncing off the walls in all directions?
So, I did for the last 3 months until I realized that 0.1 is still a positive pressure.
Ken, can you show me gas pressure without a container?
Yep.
Let's see it.
Without a container?
That's what I said.
Go to the ocean. Like where you're standing right now, you have gas pressure acting upon you. And I'm not saying that we don't have a firmament above us.
Ken.
I'm saying that if you go all the way up to the very top and you're touching the firmament, why can't you be sitting there touching the firmament above our heads and have that pressure be 0.00000000001 psi?
Well, you could.
It's still a positive pressure.
Yeah, you could, but it would have to be contained.
Yeah, absolutely. And I'm not saying that we don't have a container.
Yeah.
I'm just saying that 0.0000001 psi is still a pressure. A vacuum, like a perfect vacuum, would be 0. And then to violate the laws of nature, you would have to have a negative number. not a decimal point, but a negative.
Is it a
difference.
That's what a vacuum is. A
Right.
negative pressure system, Ken. It's sucking
There's
inward.
no such thing as a negative pressure.
Okay, is the
So if you
Sandusky
take-
Research Center pulling air through the walls, which is why they need 8 feet thick aluminum and concrete walls?
it's not pulling air through. The air outside is pushing through.
So the
Vacuum
14
never acts upon pressure. Pressure always acts upon vacuum.
Ken, the 14.7 psi is going to
Yep.
push the air in through
Into the
the
chamber.
8 feet thick aluminum walls.
Exactly.
Okay.
Exactly. And then once you get down, let's just say you achieve a perfect vacuum, right? And you get down to 0, which would be far more than 10 to the minus 17. We would be talking 0, not decimal points, but 0. Now, once you've reached a perfect vacuum that nobody can reach because it's impossible, to defy the laws of thermodynamics, you would have to get to 0 and then go beyond it.
Ken.
And we're not doing that. Space isn't even doing that. There's still atoms moving around out there, even if they're just 2 every meter.
Ken, if you get a water bottle and suck the air out, the water bottle collapses.
Absolutely.
Okay, so the air around it doesn't...
It's pushing the water to
It doesn't creep through the walls of the water bottle.
No, but
the
if you
water
suck
bottle collapses. So
Absolutely.
if the walls weren't thick enough, the vacuum would collapse into itself.
What would be making it collapse?
The negative pressure of a vacuum. Like when you suck the air out of a water bottle.
If you're sucking the air out, it's not the suction that collapses the bottle. It's the pressure outside of the bottle pushing on it. Negative pressure never acts upon a positive pressure. That is the law of thermodynamics.
Okay, I can see what you're saying. The outside presses the container in, but it still collapses. Right. It still collapses.
Absolutely.
The gas fills the space if you don't have the barrier.
Absolutely it does. Okay. And I'm not saying there's not a barrier. I believe there's a firmament. I'm a Bible believer. I believe in Yeshua.
Well, we don't need to believe it.
He saved my soul.
We don't need to believe it. There's pressure around us. We don't need to believe there's a container.
And there's pressure at 10 to the minus 17 torr. There's still pressure. It's a positive pressure.
All right. Well, yeah. If you think it's a positive pressure,
I'm not saying it's not a vacuum.
If you think it's a positive pressure sucking in all directions, I'm just gonna have to say, you don't know what positive pressure is, dude. It's a negative pressure. That's what the sucking is.
It's all about numbers. So if you have a 1 in front of you, right? A 1. Will you agree 1 is a positive?
We're back to this again.
Yeah, so 1 is positive.
When you suck the air out of the water bottle, if it doesn't have the container, right, the gas fills the space. But since there's a container, it collapses.
Absolutely.
Okay, so I mean, we can argue about numbers all day, but we're talking about
pressure.
Vacuums.
Yep, vacuum and pressure.
Vacuums that are pulling in the air around them, or the air around them
vacuum never pulls anything.
Okay, the air
only acts, like you said, if there was a perfect vacuum out in space, our atmosphere would go to it. The vacuum wouldn't suck our atmosphere out. Our atmosphere would push into it. Because high pressure always acts upon low pressure.
Hold on, I got my buddy. He's gonna get in here. 1 second. Because he's got a master's in science. I'm not the smartest flat earther, dude. I'm just more passionate.
I'm not either. I'm just saying that, like, I looked it up in my pressure conversion chart, and I'm like, 0.1 is still a positive. And, like, I don't know. I mean, maybe I am wrong, but have you ever heard of the force? What's it called? The force. I'm trying to think. It's late. It's got to be 3-4 in the morning here.
Yeah, Ken, you're cool. I like you, dude.
Dude, I love you, man. I really appreciate what you're doing, and, like, I am a flat earther, but I truly believe that we shouldn't be saying that violates the laws of thermodynamics because I'm almost 100% sure that's not true.
Well, if you didn't have a container, the gas would fill the space.
Right. Can you see me?
Yeah, I can see you.
Okay.
Yeah.
Can I write it down on a piece of paper just to like maybe show you what I'm talking about?
Yeah. Wait, no problem.
Okay. All right. Okay. So, I wonder if I can I'm just going to turn my phone around and kind of show this here, okay?
Yep.
So, 700, can you see this?
Yeah, I can see you.
Okay, so 760 torr is 1 atmosphere. You bring it all the way down to 0, and that's a perfect vacuum, okay? 0, anything below that would violate the laws of thermodynamics. But 0.1.
But you're saying negative pressure systems don't exist.
No, I'm not saying they don't exist.
Okay, so show me one. Show me one.
I'm not saying they don't exist.
So show me one.
A vacuum does exist, but a vacuum isn't negative pressure.
Okay, so I just asked you.
All a vacuum is lack of atmosphere.
Ken, I just asked you. Show me a negative pressure system. You said you couldn't, right? It doesn't exist.
Right.
Okay. So then why is it even a law if we can't have a negative pressure system to violate it?
So the way I understand it is like as far as having the higher pressures going to lower pressures, because that's basically what the law states, is that higher pressures always act upon the lower pressure.
Yeah.
Right?
Yeah.
So let me come back here again. If we have 760 torr at 1 atmosphere, if we go down like to the bottom of the Marianas Trench, we have 1,000 atmospheres, right? At the bottom of the Marianas Trench, way up here, high pressure. If we go up to the top of Mount Everest, it's 500 torr. So this is the 1 atmosphere, and we're going down here. The pressure at atmospheric or at sea level will always act upon the lower pressure. This pressure would never act upon the higher pressure. That's what the law states. But so you come down here to the perfect vacuum that can never be achieved, and it's still a pressure above it at 0.1 or 0.000000001. It's still above perfect vacuum. So until it crosses this barrier and goes into the negative, you're not defying the laws of thermodynamics. So what I'm saying is, obviously, we can agree that atmosphere has weight, right? 14.7 psi. And as you go up in the air, you have less atmosphere acting upon you, and the weight goes down. Like we just said, you go up to the top of Mount Everest, and now you're at like 500 torr instead of 760. And then if you go up even higher than that to like where the space station is, it's 0.000000001 torr. But it's still a pressure.
It's still a negative pressure by definition. That's what my friend J.M.'s saying with the Masters in Science. It's still a negative pressure by definition.
Is it negative gauge pressure or negative absolute pressure?
Negative gauge
pressure? Exactly. Because absolute pressure, because right now, I will agree with you that as you go up,
it's going to be negative. I think it's going to be negative gauge pressure, dude.
Exactly right. Because if you stand here at atmospheric pressure and you zero your gauge out.
Yeah, he said gauge. It's negative gauge pressure.
Yep, but it's not negative absolute. And that's what we're talking about.
Well, that doesn't exist.
Absolute pressure?
No.
Absolutely it does.
Negative absolute pressure.
So from 14.7 psi down to the perfect vacuum.
Hold on real quick. Red, you there?
Yeah, I'm here. Hello.
Great. Welcome to the channel. You there?
What's up, guys?
Who's Some? You there? Hello?
Hello? I can hear you, Nathan.
Your name's Some?
No.
Is that Ken?
Yeah, it's Kenny.
Okay, Red, you're here, right?
That's me. Hello.
All right. Sorry, I gotta eject Some. I don't know who that person is, and they don't have a microphone. All right. Welcome to the chat. My buddy said absolute doesn't exist. Hold on, I'm gonna ask him why he can't. Can you answer?
How does absolute not exist?
Well, you told me it doesn't exist, dude.
Absolute pressure?
Absolute negative pressure.
No, I'm talking absolute. So we're talking about two different pressures. There's gauge pressure, like gauge PSI. So right now, at sea level, I have my gauge, and it says 0, right?
Yeah.
And if I go under the ocean, a mile and a half, it'll say 15,000 psi. If I go up in the sky, it will go from 0 into the negative, like you're saying. But that's not negative pressure, that's vacuum.
That's negative gauge pressure. If you create,
negative gauge pressure,
yeah,
also known as vacuum.
So you can't have negative gauge pressure next to a pressurized atmosphere without a container. That's the violation.
So if you take that gauge and you walk up to the tippy top of Mount Everest and you watch the gauge pressure go negative, how is the negative pressure at the top of Mount Everest violating the laws of thermodynamics?
It's not a negative pressure at the top of Mount Everest. It's 500 torr. It's a positive PSI.
So is 1 torr.
Yeah.
Yep.
Cool.
Right?
Yeah.
Am I right? Yeah, so
sure.
1 torr.
But it's not 10 to the negative 17 torr, Ken. It's that negative part you're not getting, bro. That's causing the negative pressure.
The negative is still a portion of a whole number. So if 1 is positive, 0.1 is also positive. Because 0.1 is a tenth of a whole number.
It feels like you guys are going in circles around here.
It definitely does. I texted my buddy JM, said...
Does anybody else get what I'm saying?
No, my buddy JM is telling me, tell him to look up definition correct till after the decimal point. At this point, he is arguing math.
So,
yeah,
I have what do you use to calculate force? What's the equation called?
Force equals mass over acceleration?
Yep, force, mass over, yep. So, if you go down to the Marianas Trench, you got 15,000 psi acting upon you. You take that 15,000 psi and you divide it by 14.7 to find out that you have roughly 1,000 atmospheres acting above you. On you. Right?
Ken, you can't have gas pressure without a container.
I understand. I'm not saying there's not a container.
Okay. So
I know I'm saying that why can't I go up into the sky and touch my hand to the firmament and have the gas pressure be 0.00001 psi?
You can. It's still pressure. It's still pressing against the firmament.
Okay.
But there's no way space could be negative torr and next to a 0.000000001 psi pressure without the gas. Without the gas,
is just another word for psi.
Without the gas filling the space.
Torr is just another word for pressure. It's just another. It's a conversion. So there's torr, there's inches of mercury.
I'm not sure I understand what Ken is trying to argue.
I'm saying that
my buddy's saying water pressure is not gas pressure.
Absolutely, I agree. Well, no, gauge pressure is gauge pressure, whether it's gas acting upon it or water. If you have 100 psi of water pressure It's the same as 100 psi of gas pressure. The atmosphere is essentially like a liquid. It's mostly water vapor, and nitrogen, and oxygen.
It acts like a fluid, yeah, technically.
Absolutely.
Yeah. They showed a picture,
but what
guys.
I am saying is
they showed a dragonfly flying through the air, and they took infrared of the fluid around the dragonfly. Dude,
yeah.
I'm telling you guys, it reminded me of God and creation. Just the way that all the air is going around this bug every time it flaps its wings, dude. It is the most amazing thing ever. All right, go ahead. Sorry.
No, don't be sorry.
My buddy is saying you don't need a sealed container for water. You can measure or use one as the other. No. You don't need a sealed container for water. No, I wish he could get in here. I'm sorry, dude. He's got to be going to bed or something. But yeah, I don't know. Ken, we'll just have to wait till Jam gets on here, bro, because we're talking in circles.
Yeah, no worries. And I mean, I just don't like I said, the whole thing for me is, well, at least the way I understand it. It was like an epiphany that I had yesterday while I was debating this guy, trying to explain to him how it violates the laws of thermodynamics. And then my uncle was like, "No, dude, go read your book. Tell me what a positive pressure is and a negative pressure is." And he said, and he's right. There's no such thing. Like,
there's no such thing as negative gauge pressure, or no such thing as negative.
No such thing as negative
absolute. Exactly. Right. Sure.
Once you get from 760 torr atmosphere, and you bring that all the way down to 0, which is a theoretical number because a perfect vacuum at 0.
A 0 is not a perfect vacuum. That's not a perfect vacuum.
0 torr is a perfect vacuum.
Oh gosh.
0 torr. Look it up.
But
I'm telling you, look up a pressure conversion. 0 torr is a perfect vacuum. Because how much is 1 atmosphere? How many torr is 1 atmosphere?
Hold on, I'm gonna look it up if 0 torr is a perfect vacuum.
Absolutely. 760 torr is 1 atmosphere. If you take that entire atmosphere away, you're left with 0, which would be a perfect vacuum. So anything below 0 torr would violate the laws of thermodynamics. But as long as you're above 0, you're still in a pressure.
All right. I mean, Ken, you could say the same thing 20 more times, bro.
I know.
It's cool. Like,
but
you're saying it doesn't violate the second law of thermodynamics because an absolute pressure doesn't exist. So basically, you're saying nothing. Like, well, there's no way to ever know if anything violates the second law of thermodynamics.
No, that's not what I'm saying. I'm saying that as far as our atmosphere is concerned. Now, if somebody was to say, my tire exploded, or I filled up my tire with air until it imploded, that would violate the laws of thermodynamics because, no, the higher pressure in the tire would be acting upon the lower atmosphere outside of it. But if someone said, no, I filled my tire up so hard that it imploded, that's violating the laws of thermodynamics.
Nobody's saying that.